Hi, in this video we will learn how to find the relation for rate of changes of two variables if these two variables are related through another equation. In other words, we have two variables x and y which are a function of a third variable or functions of a third variable. This third variable usually is the time variable. So often time variable. So we have two x and y's, and this x and y satisfy an equation. So x and y, and they satisfy an equation. So they are related through an equation. So x and y are related by an equation. And what we want to establish a method through which we can find how the rate of change of x and rate of change of y are related. So how dx dt and dy dt are related. So this is why the title of the chapter is related rates. So we start with an equation for x and y. We find the relation for dx dt and dy dt for the rate of changes. Let's do an example. Through that example, we will learn the main steps and then go from there. X and y are functions of x and y are functions of t, and they satisfy the equation y equals to x squared minus y squared. Find the relation for rate of changes. Well, rate of changes are what? We are looking for an equation which involves dx dt and dy dt. And this equation may have x and y too. So there's just a relation for dx dt and dy dt. And you see that rate of change, dx dt, is differentiation of x with respect to t and y with respect to t. We don't have how these guys are defined as function of t, but what we have is this equation, and this the dt is the first clue for us where to start with. We have to differentiate the equation with respect to time variable. So I start with finding the dt of both sides of the equation, and you apply the chain. Well, here is just difference rule, so it is the dt of x squared minus the dt of y squared. And when you are here, you want to differentiate, yes? You know that x and y are functions of t. If someone tells you what is a d dt, let me write it here, d dx of x squared, you definitely know that it is 2x, yes? But when someone says what is the dt of x squared, this means that x is a function of t, and in that case it's not just 2x. You have to apply the chain rule. So the second thing is that apply the chain rule to complete the differentiation. Complete the differentiation. So it means that left hand side is going to be dy dt. Left hand side, right hand side is going to 2 dx dt of x minus 2 dy dt times y. And well, this now you see that we have an equation for dy dt and dx dt. Well, it involves some x and y's, but that's a relation. If someone asks you what is exactly the relation, I can write dy dt one side. I can bring this here, write dy dt and 1 minus 2y equals to 2x dx dt, and this is how they are related. And we can find that one of these guys, if I know what is x, y, and dx dt. Actually, if I'm given some numbers, for example, find dy dt when x is 0 and y is -1, and dx dt is 2. Well, now there's 4 variables in an equation. If you know 3 of them, you can find the 4th one. Just plug in these values. 1 minus 2 times -1 of dy dt. You don't know what is that. 2 times 0 is equal to, so times dx dt, which is 2. So that gives us 3 dy dt is equal to 0, and as a result of that we have dy dt, which is 0. So as you can see, everything comes from one small step, which is differentiate both sides of equation with respect to y, and then apply the chain rule. The rest is just there, and you will see what's going on. So in general, let me just write it here. In general, step 1 is differentiate both sides of the equation with respect to t. Step 2, while differentiating, you use the chain rule. Use the chain rule to complete the differentiation. And you should remember this, that this is not differentiating with respect to x. It is with respect to y. In other words, if you have x to the power n, this will be n dx dt, x to the power n minus 1. And if you have d dt of y n, this will be n dy dt y to the power n minus 1. And then when you do this thing, you will get an equation. You find an equation. which has dx dt, dy dt, and maybe x and y. And that's how you find the relation. That's what we mean by a relation, or how they are related. Okay, let's do one example and finish this video. Find example. Find dy dt at 1, 4, and when dx dt is -3. If we know that, if it is given that root x plus root y is equal to 3. Well, let's see. So here I have an equation for x and y. Then we are given points here. So x is 1, y is 1, and at that point dx dt is -3. So we have x, y, dx dt. If we have a relation for dy, for the rate of changes, I can plug in these three values and find dy dt. So as we had, so start with step 1, differentiate with respect to t. So this is root x plus root y equals to dt3. And this gives us, okay, very nice. I write this as this guy, and y to the power half. Well, derivative of 3 is 0. That's derivative of constant is 0. Okay, then the step 2, apply the chain rule. Yes, so it is half of dx dt times x to the power half minus 1 plus half of dy dt y to the power half minus 1 equals to 0. Then, well, now you can go ahead and do the substitution, plugging in the values. But let me just do a little bit simplification here. For example, this will give me 1 over 2 root x dx dt. And I can take this guy to the other side. And we see that this is 2 root y dy dt. So this is now a little bit written in a better way. So now we plug in the values. Plug in the values. Here we have x is 1, so it is 1 over 2 root 1. dx dt is -3 equals -1 over 2 root y is 4, and dy dt, we don't know what's that. In other words, we have -1 over 4 dy dt is equal to -3 over 2. From there, we can go ahead and find dy dt as -4 times -3 over 2, which is just 6. So we started with function, with an equation for x and y, and then we differentiated. We found an equation which involved dx dt and dy dt, the rate of changes. And knowing 3 of these guys, we can find the 4th one, and this was what we did for this example. Yeah, that's how we find related rates if two variables are related through an equation.